Question 6. Now this is a tricky one. There's two-part questions, both for quite a few marks each, and it's not really obvious what maths you need to do, but hopefully you are well versed in differentiation and coordinate geometry, and when you see the word normal in the question, you're thinking, well, I need to differentiate, and it's going to have something to do with perpendicularity. So part 1, differentiate to find dy by dx. But in order to do that, we first have to write y in index form. Differentiate half k x to the power minus a half. And we want to know the gradient when x is 4. So substitute that in, and we find that the gradient comes out to be a quarter k, or k over 4. Now note that that is the gradient of the tangent at point P. And in order to find the gradient of the normal at point P, we just need to take the negative reciprocal of that gradient. So now we have the gradient of the normal. Right, focus now on the line equation. Now, the way that that's been given at the moment is not particularly helpful, so rearrange it to get the gradient of that line. Now, we know that that line is parallel to the normal at P. So those two expressions that we've ended up with must be equal to each other. And if you rearrange that to get k on its own, you get k is 6. And we've done part 1. Now part 2, once you've understood what it's asking, is it's a triangle, so we need to basically know where the points of the triangle are. Well, one's at the origin, as it says. Point P, we need to know the y coordinate 4. We know that the x is 4, so we just calculate. Now that we know k, we can easily work out y to be 12. So point P is 4, 12. Now we need to work out where point Q is. Now point Q is where that normal, the normal, meets the x-axis, i.e. where y is 0. Now, what do we know about the normal so far? We know that the gradient of it is minus 2/3, and we know it passes through the point P, which is 4, 12. And when you know a point and a gradient, you can use y minus y1 equals mx minus x1 to work out the equation of the line. So substituting in our values, there we have the equation of our line. Now you can rearrange that if you want to make y the subject and simplify. We don't actually need to do that. As it is, that is the equation of the line. And what do we want to do? Go back to the question, read it again. This normal meets the x-axis at point Q. Meets the x-axis means where y is 0. So if you set y to be 0, and rearrange that for x, you get that x is 22, and therefore we now have the coordinates for point Q as well. So we've got all the ingredients now, we just need to find the area of the triangle. Now, to do that without a diagram would be rather foolish, I would think. So clear some space, and let's sketch those points. Just a sketch graph, doesn't need to be plotted very carefully, it's just for you to get a feel for what the triangle looks like. So put your point Q on there, put your point P on there, draw the triangle, and then of course, triangle area is given by half times base times height. The base is 22, the height is 12, times them together, 132 square units, and we're done.